Welcome back to Low-Level Programming Crashcasts. I'm Sheila, and with me, as always, is Victor. Before we dive in, we'd love to hear from you. If you're enjoying the show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more listeners who are passionate about low-level programming.
Thanks, Sheila. Today we're wrapping up our chapter on understanding computer architecture. We've covered a lot of ground, from the basics of computer organization to the intricacies of machine language.
That's right, Victor. And to kick things off, I've got a quiz question for our listeners. Here it is. In a modern computer system, which component typically has the fastest access time, the CPU cache, RAM, or hard disk drive?
Ooh, that's a great question, Sheila. It really gets to the heart of our discussion on memory hierarchy. I'm sure our listeners will need to think back to what we've covered about the different storage components and their characteristics. Without giving away the answer, I think this question highlights the important trade-offs in computer architecture between speed, capacity, and cost.
Absolutely, Victor. Now, before we dive into our summary, let's quickly recap some key terms we've discussed throughout this chapter. We've talked about the CPU, or Central Processing Unit, which is essentially the brain of the computer. We've also covered RAM, or Random Access Memory, which is like a computer's short-term memory, and various storage devices. Can you remind our listeners what we mean by architecture in this context?
Certainly. In computer science, architecture refers to the overall design and organization of a computer system. This includes how different components are arranged, how they interact with each other, and the principles behind their design. It's like the blueprint of a computer, defining its structure and functionality.
Thanks for that clarification, Victor. Now, let's start our summary. We began this chapter by exploring the basics of computer organization. Could you give us a quick overview of what we covered there?
Of course. We started by looking at the fundamental components of a computer system: the CPU, memory, input, output devices, and the system bus that connects them all. We compared this to a city's infrastructure, where the CPU is like the city hall, memory is like various storage facilities, I/O devices are like the city's entry and exit points, and the system bus is like the road network connecting everything.
That's a great analogy, Victor. I remember we also dove deep into CPU components and operation. Could you remind our listeners about the key parts of a CPU and how they work together?
Absolutely. The CPU has several crucial components: the arithmetic logic unit, ALU, for performing calculations, the control unit for managing operations, and various registers for temporary data storage. We compared the CPU to a chef in a kitchen, where the ALU is like the chef's hands doing the actual cooking, the control unit is like the chef's brain making decisions, and registers are like small bowls holding ingredients that are immediately needed.
That's really helpful, Victor. Now, one concept that I found particularly interesting was the memory hierarchy. Could you explain that again for our listeners?
Certainly. The memory hierarchy is a structure that organizes different types of memory based on their speed, capacity, and cost. At the top, we have the fastest but smallest and most expensive memory, CPU registers and cache. Then we move down to main memory, RAM, and finally to slower but larger and cheaper storage, like hard drives and SSDs. It's like a pyramid, with speed decreasing but capacity increasing as we move down the levels.
That's a great explanation, Victor. I think this concept really helps answer our quiz question from earlier. Speaking of which, would you like to reveal the answer now?
Sure, the component with the fastest access time is typically the CPU cache. It's designed to be extremely fast to minimize the time the CPU spends waiting for data, which is crucial for overall system performance.
Thanks, Victor. Now, let's talk about one last crucial concept we covered: the difference between machine language and high-level languages. This is where we really get into the low-level part of low-level programming, right?
Absolutely, Sheila. Machine language is the lowest-level programming language that a computer can directly understand and execute. It consists of binary code, just zeros and ones. High-level languages, on the other hand, are more human-readable and need to be translated into machine language before the computer can execute them. It's like the difference between giving someone directions in their native language versus using a series of hand signals. One is much easier for humans to understand, but the other is more directly actionable for the computer.
That's a fantastic analogy, Victor. As we wrap up this chapter, what would you say are the most important takeaways for our listeners?
Great question, Sheila. I'd say the key points are: Point 1. Understanding the basic components of a computer and how they interact is crucial for low-level programming. Point 2. The CPU is the brain of the computer, with its own internal components working together to execute instructions. Point 3. The memory hierarchy balances speed, capacity, and cost to optimize performance. 4. Machine language is the computer's native language, while high-level languages are more human-friendly but require translation. Understanding these concepts provides a solid foundation for diving deeper into low-level programming.
Thank you, Victor. That's a great summary of what we've covered. And to our listeners, remember that understanding computer architecture is crucial for effective low-level programming. It helps you write more efficient code and troubleshoot issues more effectively. Before we go, we'd love to hear from you. Visit crashcasts.com to join our Discord community, where you can discuss these concepts with fellow enthusiasts. And if you're finding value in our content, please consider supporting us on Patreon. Your support helps us continue creating these in-depth episodes. Thanks for listening, and we'll see you in the next episode, where we'll be diving into number systems and data representation.